This is just a quick review of matrices. We'll be talking about addition, subtraction, multiplication, as well as finding the determinant and the inverse. So we'll jump right in it in terms of addition. And we'll also add in a scalar there. Since we've done this before, I have high expectations for you guys. Okay, so the biggest thing is with addition or subtraction of matrices, the key is the matrices have to be the same size. Or same dimensions, I should say. Okay, so looking at this, remember it's in the terms of rows by columns. So in this case, I have 2 rows, 3 columns. So I have a 2 by 3 and a 2 by 3. Since I have that scalar there of this 2, that multiplication, I'm going to go ahead and apply that to that matrix and rewrite this and then do my addition. Now, it gets a little tricky, remember, if you have a negative there. I personally like to distribute the negative with it and then do addition, but that's up to you. So now that I've done the scalar multiplication, now I can just straight add these, and I add them based on the element location. So the 1 and the 0 go together. You know, the 2 and this 2 go together. The 6 and the 4. So you're just going in that addition. It's multiplication that we have some issues potentially, or that it's a little bit different, I should say. So like I said, you're just adding straight across in the location of the elements, which isn't that big of a deal. And your final answer would be 1, 4, 10 in the first row, 1, 2, 5 in the second row. Like I said, addition and subtraction, piece of cake. Multiplication, a little bit different. With multiplication, it's not necessarily that you have to have the same dimensions. So it has to have the inside numbers here have to be the same. So let's go with 3, -1, 2, 6. So my columns, I have 2 columns, which means that I need 2 rows. So with this matrix, let's go with 4 and 8. So notice, I always like to write the dimensions so I know what my end result is going to be. So this is a 2 by 2, and this one here is a 2 by 1. So if you remember this, it's like canceling out. The middle numbers are the same, and it's like canceling out, and we're going to be left with, ooh, did not want that in green, sorry. We're going to be left with a 2 by 1 as an end result. So when we're looking for these numbers, remember, it's multiplying the row by the column. So I'm going to multiply this by this in order to get that final answer. Personally, I like to actually set this up a little bit differently, but I'll leave it how it is. So I have 3 times 4 plus -1 times 8. So I'm going to get 12 plus -8, which is going to result in a 4. The next one, I'm going to take my second row by my column. So I have 2 by 4, or 2 times 4 plus 6 times 8. 2 times 4 gives me 8. 6 times 8 gives me 48. Realistically, you have 8 plus another 8. You know, so it'd be 7 times 8 to give us that 56. And that right here would be our end result for matrix multiplication. And last but not least, talking about an inverse matrix. But before we talk about an inverse matrix, we need to first talk about the determinant, because the determinant is going to help you determine, it's kind of odd, I shouldn't say it that way, but is going to help you to find your inverse. So determinant must be a square matrix. Now, I've always shown you with a 2 by 2, and then we've always done the calculator stuff with anything that was greater than a 2 by 2. Same thing will apply. I'll run through that with you in class on how to find those inverses and determinants using a calculator. So to define your determinant, you take A times D minus B times C. So if this were my matrix, I'd have 6 times 0 minus 4 times negative 1. So in this case, my determinant would be 4. Now the determinant is used in order to find the inverse. So if the determinant has to be a square matrix, an inverse also has to be a square matrix. So let's say that we have 4 times 2 and 6 and negative 1. Actually, let's go a positive 1. So whenever we're looking for an inverse, it's to the power of negative 1. So when we're looking at this situation, we're going to have 1 over the determinant times, and if you remember, some things get switched around. D and A get flip-flopped, and then B and C become the opposite of what we see. So I'm first going to figure out the determinant. So I have 4 times 2 minus 1 times 6, which is going to give me 8 minus 6 to give me 2. Okay, so now with that information, I have 1 over 2. I'm going to flip the corners here. So I'm flipping these two around. Then these two will match up and have opposite signs. So this is now a 2, negative 1, negative 6, and a 4. So I'm going to use this information to then distribute that half, because it's like a scalar. I'm going to distribute that half into everything to get my final answer. So I have 1, negative a half, negative 3, and 2. This would result in my final inverse because I've done the determinant, I've switched everything around, and then I multiplied that 1 over the determinant to everything. Again, I will show you guys all of this stuff again on a calculator in order to do some stuff quickly in terms of it might be a 3 by 3, or it could be in a larger matrix that we could do matrix multiplication and that kind of stuff. But just so you guys are aware, this is my inverse determinant, multiplication and addition subtraction of matrices. Oh, one other thing. In inverse here, you have a 1 over determinant. If your determinant equals 0, obviously you can't divide by 0, so your inverse would not exist. Just something to think about, but just wanted to touch base on that.